Okay, this is Math 2, Unit 12, Lesson 9, or Unit 12B5, whichever one you want to look at. Looking at Form K, some homework help today. Going to do a few of these here with you. Okay, to begin with, first I want you to do some graphing. Alright, so let's take a look at number 2 first of all. Let's start here with number 2. We start at a point 0, 3, 1, 2, 3, so a point there. A point at 1, 1, so about there. I have a point at 2, 0, so about there. And at 3, I have one at 1. So already I can see this graph is starting to make this curve like a parabola, which tells me for the most part, because it curves, this is going to be a quadratic type of graph because it makes that curve. Okay, so our options essentially, we have linear, which is going to be a line. We have quadratic, which is going to make the curve. And then we're going to have exponential, which is probably going to shoot off and get steeper and steeper, or do something crazy like that. Kind of get smaller here, steeper there, as you go up or down. Okay, for the next one here, let's look at this one. We have a couple points here. We have -2, -1, 0, and 1. So here's -2, -1, 0, and 1. And at their y values, we have negatives, 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 all the way down to -2. All right, so at -2, we're at -0.25, so somewhere about here. At -1, we're about halfway between 0 and 1, so about here. At 0, we are at 1, and at 1, we are at -2. So this graph here tends to be getting further apart as we go along, and it has a funny little curve like that, and it gets smaller and smaller, probably never quite crossing that axis there. We would call this one exponential because of the way it makes that curve there. Okay, let's take a look at the next one here. We're going to use the x value 6, 4, 2, 0, so we're really going this way. 0, 1, 2, 3, 4, 5, 6, and we're on positive 1, 2, 3, 4, 5, 6. I should count that up first. -6, we're at 6. -4, we're at 4. -2, we're at 2, and 0, we're at 0. So we probably would call this a linear function there because it makes a nice line. Okay, down at number 7, looking for how this works here. Again, if you watch the video here, what you want to look at is the differences in the y values. Okay, a couple kind of simple rules here. If the differences are the same by adding or subtracting, it's most likely a linear function. If the differences are the same by multiplying, these are by multiplying, then typically those would be exponential. If though the first differences are the same, and the second difference, if the first differences are different, and then the second set is the same, that tells you you're dealing with a quadratic. Okay, so let me show you how this works real quick. So from here to here, we're going down 2. From here to here, we're going less than 6. Here to here, we're going -10. Here to here, we're going minus more. That means can't think right now. 14, right? 14. So we're changing the value every time. This is a different one. So it's not linear because it would be the same if it was. It's not exponential because it would be the same if it was with multiplication. And there's not a multiplication there that makes that work. So right now it's different. So most likely it's quadratic. When you look at the second level, to go from 2 to -6, you can see we have a difference of 4. 6 to 10 is a difference of 4, and 10 to 4 is a difference of 4. That's the same. So because I have something different here and the same there, this one would be quadratic. Okay? On number 8, we're going from 1 to -3, so that's going to be, I could look at it, start and say, well, maybe it's a 4. And -3 to 9, I could say, well, maybe that's a 6. But if I notice, 1 times 3, 1 times the -3, and 1 times 3 gets me there. So it's a times 3 difference. 3 to 9 is a times 3 difference. 9 to 27 is a times 3 difference. And 27 to 81 is a times 3. So because I have the same deal and I'm multiplying, we would call that exponential. Alright, take a look at some of the backside here. Wrong backside, sorry. Backside there. Alright, for this part here, I'm not sure you have to do all this. When I'm looking here, I see 2 to 4 is times 2, 4 to 8 is times 2, so that's times 2, a times 2, a times 2. So already I can tell that it's going to be exponential. Now in terms of writing that equation, what I like to look at is, I like to look at the zero value, okay, because the zero value is going to tell me what number goes out in front. So I'm going to start with a negative 2 out in front. Now from an exponential part, I'm going to look at what my value is here. I'm multiplying by 2, and that exponential part is the x value right here because that's what's going to change. So that's my multiplication value goes here, and my leading term goes there, at negative 2. Okay, so let me show you another exponential while we're on it. This one is exponential as well, and let's look at y. To go from 12 to 6, we are dividing by 2. 6 to 3, we are dividing by 2. 3 to a half, we're dividing by 2. So that's going to be exponential for that reason there. Looking at the 0, this becomes my leading term, so y equals 3. And then we're going to take this part here to say what were we doing each time? We're either dividing by 2, which means multiplying by a half, right? And that is what is my exponential part there. On these ones over here, we have going from negative 2 to negative 5. This is a difference of 3, difference of 3, difference of 3. So this would be linear. When we have a linear function, remember y equals mx plus b. This is our slope for what we're doing, and this is our y-intercept. So our y-intercept is right here at the 0. So y is going to equal something times x minus 2, because that's my y-intercept. So what am I doing each time? I'm going from 0, or just graph this out here, at 0 I'm at negative 2, right? And at 1 I'm at negative 5. So we're going down. So my slope needs to be negative. And what am I doing? I'm going down 3 over 1. I'm going down 3 over 1. So my slope is negative 3. And I could write negative 3 over 1 if I wanted to, but I can just leave it at negative 3x minus 2. Okay? On the quadratic one, which is probably what's next, let's take a look at y. We're going from 1 to 1.5. Okay? So there's a difference there of 0.5, right? 0.5. And from here to here, there's a difference of 1.5. And from here to here, we have a difference of 2.5, right? And so my difference changes. That's different on this side. But here to here, I'm adding 1, right? So now they're the same. It tells me it's quadratic. So when we do a quadratic, same idea. I'm going to do y equals something. Now I'm going to end up with an x squared because it's quadratic. I look at my y-intercept is 0 plus 1, so I know my intercept is there. And then I have to decide what is happening here in the front part. What's my, not my slope, but what's happening, my differences here. And if I notice, what is happening is each time, let's look at here, from 1.5 to 3, I am going to be getting a little bit larger. I'm getting a little bit larger by about half of what it is, right? So what's half of 1? 0.5. So I'm getting larger by a half. So I'm going to say I'm getting larger by a half each time, all the way through. Okay? You want to do the same things for the ones down below, okay, whatever they might be. So let's take a look at number 18 real quick. We have negative 1. We're going down to negative 6, negative 21. Wow, a lot of negative numbers here. Not a lot of positives. So I'm going to make mine like this with negative 1, 0, 1, 2, 3, 4. And we're going all the way down to negative 21. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So way down there. Not even sure where we're going. So negative 1, 6 is somewhere about here. 0, negative 1 is about here. 2, comma, negative 3 is somewhere around here. 3, comma, negative 10, we're going down. And 4, down. So either way, we have some kind of little curve like this, right? We got a curve, which tells me we're going to be quadratic. for that equation there. Okay? Couple things you've noticed. Well, we'll leave it at that. So, figure out what those graphs are going to be. That's the main part of what you need for this unit, not so much writing the equations. So I'll pause there. I'm not sure how much your teachers want you to do. So we'll leave it at that. Hope that helps a little bit.